Today we're going to be going over lidocaine synthesis, and to begin you want to start by combining 2,6-dimethylanilene with 2-chloroacetic chloride and acetyl acid. It gives a yellow color, you'll notice, and then you want to give this flask a gentle swirl and put it on a hot plate for about roughly 4 minutes. After the 4 minutes is over, you then want to add about 5 times the amount of dimethylamine and toluene to your 2-chloroacetamide. And you're going to add hydrochloric salt into that mixture too. And when you put that all into like the flask and put it into an ice bath, you should see a white precipitate start to form. Once that starts to form, you want to add hexane and slowly rinse the flask. And keep in mind that the ammonium chloride is water soluble, so you don't want to ruin that. And your precipitate that you get is a lidocaine free base. The limiting reagent in this case is going to be the 2,6-dimethylaniline. We know this because it has the lowest yield, and we can calculate that by taking the mass of our dimethylanilane and multiplying it by 1 millimole over its molecular mass, which is 0.12118 milligrams. Then you multiply that by the 1 millimole of N-chloroacetamide over 1 millimole of dimethylanilane. Finally, you multiply that by the molecular weight of the N-chloroacetamide, which is 0.19766 milligrams. And you want to put that over 1 millimole, which is going to give us our final product. In this case, the 2,6-dimethylanilane is the smallest amount being made. In this reaction, it's important to have both acids and bases. This is because of the protonation that lidocaine goes through. The diethylamine transfers a hydrogen proton onto the lidocaine hydrochloride, which creates the product of lidocaine dimethyl ammonium chloride, which is again water soluble. And you can see that over here, the dimethylamine, I'm not saying that right, but it's transferring the hydrogen proton over to the lidocaine, which is then, making it into the diethyl ammonium chloride and lidocaine instead of a lidocaine hydrochloride.